Good afternoon to all of you, and welcome to the Smart Grid Educational Series webinar for September 2013. I'm your moderator, Irfan Ibrahim, and we are very happy to have William J. Miller, who is going to be presenting on the XMPP standard, and he'll be talking about big data and the smart grid. As many of you who are on this call know, the establishment of smart grid over the last decade has increased the amount of data that we're collecting from intelligent devices, and the forecast for how much data will be collected in the future is just astronomical. And in this environment where there's so much data being generated from so many devices, and William will get into more detail of how granular a level data can be collected, the issue is that there has to be well-established standards by which data is kept and transmitted and stored and also processed. And in the absence of such standards, if we had very proprietary environments, then we would not have the rapid implementation of these technologies, because it will be very difficult for one vendor product to work with another. And quite often we'll find a very heterogeneous environment in which there will be different vendors with different technologies all trying to work together. So this is an attempt at looking at the smart grid at the most granular level and looking at some standards that make sense at that level, and then doing a bottoms-up approach, if you may, to put together systems and then eventually systems of systems with the concept of security built in right from scratch. And this is the big value add, whereas in the past we had a lot of open systems that didn't have many security controls, and then security controls were added. Here we're doing a complete bottoms-up approach with very, very specific ideas of how to secure against certain types of threats. And there are very few people like William Miller in our industry who understand this at that granular level and has had a successful career spanning several, I won't say several, but few decades for learning about this and then making the recommendations in this particular standard that he'll be talking about. So I'm really happy that William is here to share with us. And from this, my hope is that you will all think about how this standard can be used in your various areas of practice in smart grid. So with that, I will pass the ball on to William, and you can start the presentation this time, William.
Okay. Can you hear me okay, Irfan?
Yes, it's great.
Okay, great. Okay, I see quite a few more people joining right now. And I welcome everybody to the session this afternoon. And today we're going to talk about XMPP, which is Extensible Markup and Presence Protocol, and big data and the smart grid. And I'm chairman of the ISO, it's a joint effort between ISO, IEC, and IEEE. It's called P21451-1-4. Big number, that's why we call it Sensei IoT. Let me just move this forward and show you what our agenda is. Okay, these are the largest scale of the agenda today. I'm going to touch base a little bit about what's known as the Internet of Things. I'm sure you've all heard about that. And a bit about the standards. There's going to be a bit of information in here, which I believe the presentation will be available to everyone. So you can get a lot of the details here on the constructs, which are in this presentation. And I'm also going to touch base with big data for smart grid and some use cases with smart grid. I did update some of these slides only within the last hour with a lot of new information that we've just got. This is a subject area between Internet of Things, big data, and of course smart grid. It changes every day. So I wanted to give you guys the benefit of the latest stuff. So I added a little bit more information. The Internet of Things. I guess today we're hearing a lot about this. It's sometimes synonymously stated as machine to machine. I guess officially there's not really been any defined standard for the Internet of Things. So I guess you might say the P21451-1-4 effort is an attempt to do that. And of course the smart grid is a perfect use case because there's just so many areas of the smart grid, from the generation side, transmission side, all the way down to the consumer, which will make use of sensors. And to have that data be able to be made available, provide alerts across the board is really necessary. And it's been quite a challenge over the last 3 or 4 years to try and make that happen. I think we still aren't quite there. And one of the most central elements that I wanted to bring to the forefront here is social media is really driving everything right now. Because with the advent of use of smartphones, smart devices, iPads, and obviously faster and faster computers, and of course broadband access to be able to do this, we're seeing the internet become a even more major part of our life. And the Internet of Things is in fact that. Whether you'll wear it on your person, whether you'll have it at your home, whether it'll be built into the car, social media is integrated to all of that. I wanted to kind of, hopefully you can see all this on the web. This is kind of a diagram showing what the evolution of the internet looks like from, oh gosh, all the way back almost 30 or more years ago. We're at about Web 2.0 right now. But what we're going to discuss today is what is now known as the Semantic Web 3.0. And as you can see, it's kind of topping out toward the top of the chart. We're moving into the area of smartness, if you will, where we're going to expect machines to have far more intelligence. And I believe this is the things that are going to fulfill the vision of the smart grid. This is kind of a mind map. Once again, you may have to get out your microscope to read some of these things. But I thought this would be useful. You can look at it in greater detail later. But you'll see how so many areas are now playing into what we see as the Internet of Things, from healthcare, transportation systems, smart buildings, smart appliances, smart manufacturing, and obviously critical infrastructure protection and environmental, obviously our smart cars. Seems like everything has the word smart in it, but I guess we still need to put more smarts. So this is one of those things, I guess. And of course, you're seeing all the areas that have to be addressed that are commonly discussed, whether it was the requirements areas and all those stakeholders that are interested in this space. There's certainly a lot of information to learn. One of the key elements for the Internet of Things is identification. And within the P21451-1-4 standard, we're adopting the use of the ISO 29161, which is an automatic identification for the Internet of Things. It was developed through the cargo shipping industry, which is probably the other, if not the largest use case on the planet, which currently is being used in everybody from Federal Express, DHL, being able to track those goods all over the planet. And of course now we want to integrate sensors into various goods, including the trucks, pallets, and so on. So you can see why ISO and this particular group, which is JTC1 SG31, has been so helpful in helping to develop that. And also I want to acknowledge TC122, which is an Internet of Things group. The basic identifier that you see like in the bottom here is making use of what's called a JID, and I'll go into a little more details on this later. but it looks very synonymously with what you would see in an email address.
William, can you adjust how you're speaking into your microphone? There seems to be a slight echo in your speech.
Really?
Yeah, and I saw this coming. So are you speaking on a speakerphone or?
No, I've got hands-free on my cell phone we're calling in on right now.
Okay. So maybe it's just the distance or something, but.
No, you're perfectly clear to me here. I have no echo. I'll just hold the microphone a little closer. Maybe you're hearing something of it at the distance from my mouth.
Okay, very good. Go ahead.
All right. Well, a little bit further here on the P21451-1-4 standard. This is a standard to make use of the extensible markup and presence protocol. Not everybody realizes that social media and many of the common applications you use today, such as Skype and Yahoo, MSN, they all use XMPP. And of course, it's extremely scalable. We're able to use that to reach all over the planet right now from our mobile devices, our home computers, and so on. And of course, we use that for video and voice. But we really hadn't used it in the past for sending sensor type data. So it's obviously a natural fit to be able to extend the use of streaming XML, is what XMPP is, to be able to do machine-to-machine and sensor networks. And what you'll see in this presentation is how we're doing that. This effort is hosted by Dr. Kang Lee at the National Institute of Standards, and he is also chairman of IEEE TC9 Sensor Technology, and also was co-hosted by Craig Harmon, who is chairman of the ISO JTC1 SC31 Automatic Identification Working Group. This is kind of an overview of how we're working right now with the 21451 standard. You'll see that XMPP can provide a transport for various different types of services, including HTTP, as well as SOAP and standard TCP, and of course, what you see here is what's termed as an ABSI. That's an abstracted interface, which I'll talk about, which will allow us to even interface to legacy devices. So you're going to learn a bit more about that. And of course, I should tell you, if you're not aware, the XMPP is handled by the XMPP Standards Foundation, called the XSF. There's a lot of acronyms in this presentation. And basically, they are, it's an open standard for instant messaging and presence within the IETF. And of course, there's been a number of IETF RFCs about this. There's many more now, and it's constantly growing. There's a link if you wish to learn more about the various RFCs, as well as other aspects of XMPP. You can go to xmpp.org, which is the link I have there, and I suggest you do that to learn a bit more. The overall concept, which is what I'm showing you now, is a service-oriented architecture. And basically, the center is to provide message routing between the endpoints where a consumer can communicate with a particular provider or multiple providers. And the center point, handles such services as the registration, security, joining the network, and it can do other things as we go along. And you're going to learn a bit about, when we get to the big data, of how it can be used to pass this information in particular a smart grid scenario. One of the nice elements of XMPP is addressing the scalability problem. Today, when we're doing a tie-in to sensors in the field, we may use a VPN, which you can see on the left. You can provision VPN services to communicate to endpoints over any wire-to-wireless services. What we're doing with XMPP now is putting in a broker is called a service broker, which can reside in between. And again, it can reside on a wireless type of network. And from the broker, then you can associate with other groups and be able to have a point-to-multi-point type connection. And that also includes connection with mobile devices. What you see on the right side now is where it discusses use of federated services. And you're seeing this today in services that like Google offers with the EC2 cloud and our other clouds that you've seen like Amazon. These are very powerful cloud computing architectures, and these are federated services. But what we would urge you to see with to help service the Internet of Things is a federated service of connections that is not unlike what we see today, by the way, that emerged from the old analog system. We became a digital phone system. And then eventually, which used the SIP protocol, by the way. But then as we now have moved into the Internet, where we essentially used HTML, SOAP services, but now we need to expand that even further. And using this federated approach, we can do that. This is kind of an overview picture, which kind of shows you the interconnections using a cloud service to do that. And you can connect your private cloud, which might be on your LAN or your WAN infrastructure, to the Internet. And this can be provided through use of XMPP. And of course, such other services, such as single sign-on, can be provided as part of those services. This is a nice picture that kind of shows that separation, because I want you to kind of envision just how we have our digital phone services today. The PBX, I'm sure, has much stirring many years ago when we switched off of the analog phone system, and people didn't really understand how that really did its thing. But now we have a worldwide connection of phone services. Now we're moving to the next level, which we can now provide various services interconnected via the Internet, and using XMPP, we'll be able to do that. I'm going to discuss a little bit about different abstracted services, because one of the issues that within our working groups was that there was a lot of people began to show up and join because they had used XMPP in different ways. And the various different abstractions are the following. One in which you may want to communicate via a gateway to your particular device. And or you may want to have your device have XMPP built directly into it. So you may have some direct I/O that's going to interface right into it, just like your smartphone does today, which has accelerators and GPSs and other things built right in. Obviously, having a legacy device adapter would be important, where you could communicate Modbus, for example, over XMPP. And of course, the other one that just recently came about was using OPC UA over XMPP. We've had the OPC Foundation now come and talk to us that they are very interested in doing this because they would like to tie OPC servers via UA to support such installations as smart grid, transportation systems, building automation systems. And just pictorially, I want to show you just what we're talking about. If you were doing like a service one and connecting to, for example, an internal service bus, you might just have this abstraction on the left that's doing a request response using XMPP messaging, and then you may use something we'll talk about further here, which is a efficient XML interchange as part of XMPP. I'll tell you more about that so you won't be in the dark. The second one is where you may be tying in direct I/O. Again, it looks very similar, except now you have to do the conversion of that I/O rather than in a field connecting back through a gateway over its service bus. You're going to be able to tie your actual sensor directly into your box. And of course, the third one here is if you are doing an abstracted interface, then you may want to have your standard physical interface, which is going to bring a legacy protocol in like Modbus or even DMP. And again, you have to have a database. But from that database, you can now have a XMPP interface. Everything you see to the left, which is handling the XMPP traffic, is now becomes a common transport. And that transport now can transport any one of these I/O systems to an endpoint. I'm going to show you a little bit about the particular requests and responses. I'm not going to go through all the detail, but I wanted you to see what it looks like, and I'm going to invite you to learn more about this later, which I'm sure when you download this, you can go into this and learn more. There are XCPs, and it's also defined in our standard. What you see right here is a discovery request. Whenever you would have one of these XMPP interfaces, you would have to send a message to your broker, in this case, and request various features that you would be looking for. And in this case, this message goes out and says, well, I need you to support interoperability, and it's obviously mandatory. Sensor data control, that it supports concentration of that data, so on and so forth. And again, if you need other types of features, those can all be requested. Your initial discovery to the system. Now the response may be just as simple as, yes, we have all those things. In this case, it happened to be interoperability was a response. This is a connection saying, well, I want to let me know what types of interfaces that you have available. And it says, get the interfaces. Well, the response would be all the types of interfaces that are available from the XMPP interface. Now, when we want to actually get the data, then we have to send what's called a sensor data request. And this is exactly what it looks like. It's all in XML. And of course, here is a response. This happens to be one where I was requesting it from a device that actually had a GPS in it, and it also had a sensor. Of course, this could be a device that has multiple sensors. It may have other information as well. But this is more or less what it looks like. I don't want to take you through all the detail at this point. One of the important elements that's now emerging from our group is there's going to be a new URI. This is called HTTP over XMPP. And figured by about the first quarter of 2014, you'll begin to see this available where XMPP will be built right into your browser. So you'll type in, rather than saying HTTP or HTTPS, you'll type in HTTPX is an X-ray, and you will establish a XMPP connection. One of the beauties of this is that you'll now be able to send standard HTTP data traffic over an XMPP transport. So it'll look all the same to you, other than now the security will be built in. And in such situations, like if you were to be communicating with your bank or you're doing any kind of merchant transactions today, you're talking directly to their server. And of course, you provide a login and password. But of course, there's a lot of vulnerabilities there for all us people who follow what happens with web servers. You have an SSL connection. But what we see here with using a service broker, this brokerage is like an intermediary that can be assured that that end site is who it says it is. Because you know today when we're using the internet, you can't always trust what you're seeing. I mean, you may get an email with a link in it, you click on it, it comes up with a site that looks very familiar to you, but if you look real closely, you'll probably find out that it comes from somewhere in Eastern Europe or who knows where. And obviously, they're fishing for your information. Obviously, these are kinds of conditions that have pretty much meant why, particularly like utilities, would be afraid. I'm sure I'm afraid of doing it right now. That you just have to be looking very carefully at the information you may be sending over the web to be sure that you're actually talking to the right place. And of course, this is defined in an XCP 0332, which if you check on your web browser, you'll be able to download a copy of that. I've tried to make reference in the presentation of various XCPs that I'm discussing. One of the other things that is going to help this along is something called EXI, which is been developed through the IETF, called Efficient XML Interchange. And what this basically does is allows you then to encode the data that you're going to send across the web. I'll go into this in a little more detail in a moment. Okay, I'm going to jump forward into our big data discussion. And what is big data? I mean, it's been something that a lot of people still don't really have a good handles on, but it's basically handling the large amount of data and the amount of that data that's being created around the planet. We've obviously had terabytes, if not petabytes of data that people have been collecting from all kinds of areas, from geospatial information, downloading imagery. Obviously now with the smart grid, we're going to generate a lot more with trying to collect information from homes, businesses, the power grid and its current status. But obviously there's many, many areas like Irfan said earlier. And it's generally been pretty impractical to do that with conventional methods. So what we'll discuss here is about how that's being addressed in the way of big data today. And of course, some of the characteristics here is that we want to move the intelligence out to the edge. And one of the products, I'm going to call it a product, let's call it approaches, because there's a number of companies who make systems that use what's called Hadoop. And the Hadoop MapReduce capability is it basically breaks up the tasks into smaller tasks and to work with a very large data set. And of course, then it generally makes that in the form of unstructured data that can be combined with other structured data from relational databases using SQL. Hadoop uses what's known as NoSQL. Of course, it doesn't mean no. It means not only SQL. Because actually one of the best benefits I like is the idea that you can have a hybrid system that combines the use of Hadoop, with your traditional relational database systems. Of course, one of the things I just mentioned at the bottom here was a key element that I'm going to discuss here is the use of data compression. Because probably most of the things that we have today would really not work real well unless we had very robust data compression capabilities. Even though things have gotten faster, I think you'll see at the core there is something that's providing some data compression capability. I did mention a little bit about this already, but EXI, of course, was a recommendation from the World Wide Web Consortium, and of course it's also mentioned in IETF. And I've already discussed this, but it's defined in XCP 0322. This is actually some of the XML coding that you would use using XMPP. And at the top, we're initiating a TLS session. And then after we do that, we want to tell the server that we want to set up a particular streaming session. So we have to tell it the particular method of data compression that we're going to use. And I think that's an important element to realize, that when we're having this server-to-server or client-to-server kind of relationship, we have to ask questions. These request responses have to go on between the devices so that they know how you want to talk. One of the compressions that's used with big data is called Peazip 2. And again, this is an open source file compressor that uses the Barrow-Wheeler algorithm. And the compressor uses a Huffman encoding, but it creates a series of strings, actually, that makes it really nice that even if you were to lose a sector of information, it's recoverable quite nice. nicely, and it lends itself to this splitting approach that we're going to discuss. And in retaining all the data from the sensor systems using sensor data, it could be applied for such applications as AMI or DER. Another algorithm that's coming along in research here is called Qzip X. And again, this is a Huffman encoding with LZW with block sorting. Its targeted initially was for use with constrained memory devices such as RFID. Again, RFID is viewed as an Internet of Things, and it's used very widely all over the world today. They don't necessarily integrate sensors at this moment, but in our working group under 21451-7, it defines the use of sensors with RFID and GPS. So being able to use this with constrained memory devices is going to be very useful. One of the things that drove the use of this compression algorithm was the idea that we're shipping goods or we receive something and we really don't know what it is. We don't have the details, and we have to go and find it somewhere. And if we can actually put that information, whether it was the custom border information, if it was tracking information, if it was a data sheet, specification, might be just a page or two of information right there in the RFID itself, it'd be very helpful. There's been a lot of material lost because we, quite frankly, even though we had an RFID tag, if you weren't near a server, you weren't able to recognize where it's at. But you can see how that's going to apply. But one of the differences here is that it's using a machine learning approach. So it's able to use very little data to be able to reconstruct the information. So I'm pretty excited about this one. This is kind of a diagram showing what big data looks like using Hadoop. And of course, this was initially developed through Google and used with the Amazon cloud, and a lot of the good people out there in Silicon Valley who've been very busy with this all the time. But you can see how that breaks all the information up into information that can be used on commodity computers. So putting together a system that might be hundreds of commodity PCs can now perform as a fast parallel processor. And you can see here from the diagram architecturally at the core, you're seeing how that information is used using Peazip 2, for example, to be able to data compress this. It's an asymmetric algorithm, so it's not as fast when you first encode it, but it's very fast, and obviously when you decode it. So that's very helpful in these applications where once we've got the data up to the data source, we can read it very quickly. Just a little more data on the Hadoop MapReduce. I guess I'm going to leave this to you to look up in more detail. But one of the use cases for using big data is big data analytics. If we collect all the data from various aspects of smart grid, for example, and we want to analyze some characteristics of that information, all depends on what it is, but we can derive that information via use of the data analytics capability. So the big data systems provide a number of services, whether it's retention of the information, data analytic information, visualization of that data. They can all be done through the cloud. I just put this diagram in only an hour ago. I actually just got it from our working group. I'm on the NIST Big Data working group, which we have meetings just about every day right now, on a new reference architecture. And I'm only going to briefly go through this because it would take a long time to better explain it. But within the architecture, which can make use of things like Hadoop, we have to maybe look at the different types of data that's out there and be able to determine, well, how do we deal with it? Because it's not all in a raw data form. That could actually be very useful. It may be in different formats. Or if we want to have that information brought together in some particular way, so that if we had data, we had the location information, we had the sensor information, we're going to call to get maybe map data, or we're going to link it with other web services that currently exist so that we can bring up Google Map or Google Earth and be able to have that and call it into our machines, whether it's on a mobile device or on your notebook computer. So that's what we're seeing here at the core is those analytics, definition, visualization, access, and of course security. That's what this larger box is. We were talking about this quite a bit today, is how do we secure all this? And obviously that's a pretty complex problem. What's the next one? Okay. I wanted to show you the diagram that I showed you earlier where you can actually make use of a big data system in conjunction with XMPP, because it's now via the service broker able to provide a transport of the messaging from various endpoints in the system into your big data cluster. That cluster could be located locally or it could be located in multiple places. And how you decide to send that data to a given machine, which is going to respond with a particular service that you might need, that could all be at least routed and secured using XMPP capabilities. And that includes out to your mobile devices, which if you have a mobile device today, you probably know that Android is different than an Apple, is different than a Microsoft machine. And each one of the systems that they talk to, the web page you see on your mobile device is not exactly the same as the one you have on your notebook. So the devices have to communicate and find out all this other information in advance and be able to then pass all this along. Let me talk just a little bit now of some other use cases and some of the key challenges that have represented the slow adoption at times of smart grid capabilities. And at the top, what we see is that the Internet's not really been effectively used. I mean, we see it in the form of web pages and some information that's provided for consumers. But have we really leveraged it in the manner I've been discussing? Not just yet. We obviously use a lot of social media capabilities, but we haven't had this full integration of the sensors with those devices. You will be seeing more mobile devices coming out with sensors built in, and hopefully we'll see them use the XMPP capabilities. Various things like software has had a lot of implementation variances, and that includes protocols themselves. So being able to communicate with a given device and query what type of protocol it is, possibly what manufacturer it came from, these are the things that can help provide assured interoperability, which is the third item I'm mentioning here. You know, we want things to be built to standards, but obviously there are variances even within standards. And having this means where we have a conversation with the device and it tells us more information about itself, and we may need that to be able to make a better decision as to whether we can communicate with that system. Today, a lot of systems are peer-to-peer, and that kind of limits the scalability. We need this ability where we can reach literally millions, if not billions, of devices, which is a really big challenge. Persistence. This is a word that people are not necessarily used a lot, but to be able to know if that actual device is available. And that's one thing XMPP does provide. If you've used Skype or Yahoo, if you were chatting with your friends, you see that they're available, and then you're able to contact them. It's the same basic capability. If you were to connect up a sensor, then you would know that it's available and that it's actually ready to talk to you. That's kind of an open-ended approach right now. There's obviously a number of cyber vulnerabilities into the whole architecture, and providing a lot of built-in capabilities that are part of the XMPP, we believe that's going to help out quite a bit. And a lot of people have actually seen that they felt that IP addresses were going to answer all the questions. And even though we needed and are still making the transition between IPv4 to IPv6, there is actually a need to have more information. As I said earlier, you can have the address, that we have to know more about the particular protocol now that it might be sending and what other types of resources are available or methods. a lot of systems today, you would be using polling on a local basis, which is what we've used for years for PLC systems and others, and that works really great for the local area. But it's really a problem when trying to use the internet, which is obviously slow to its adoption. You do not have to perform a polling action with the XMPP type systems. And the security of the system ends up becoming very multi-layered because you have the service broker that can be in the middle, and he makes sure that he's talking to everybody who's actually authorized to join. You have your TLS is built in, and of course you can add other things as far as the security in the system. Basically, the cost and complexity today is still pretty high, and when we do it the way we traditionally have done it, it still escalates quite a bit in the cost and complexity of actually doing that. These are some of the things that we feel that the Sensei IoT is going to help on in the area of cyber defense. And the sensor IoT is technology agnostic and protocol independent. As I said, you're able to send legacy protocols if you wish, or it doesn't matter what kind of technology you're going to use. It could be anything from Wi-Fi to cellular to wired communications. It really doesn't matter. And I mentioned about use of transport layer security. XMPP is also firewall friendly, which is helpful. And since there's a lot of common exposures at port 80, XMPP data traffic is using addresses up in the 5,000 range. So it doesn't even come down below 100, which would penetrate the operating systems. Of course, you're now providing a semantic conversation using XML to be able to do these interchanges, which is quite useful. There's so many systems use XML today. You would be able to pass those types of constructs via XMPP. I mentioned about use of the broker and that you're actually performing a trust relationship with your various machines, users, as well as applications that you're going to communicate with. And the capability of providing single sign-on. We're not quite there yet, but it's been taking shape that this is a capability that's really needed so that you won't have to be carrying around a lot of login and passwords right now. I must have 60 pages of things right now. And of course, you can apply other things like digital signing, and I mentioned earlier about use of EXI capabilities. And of course, we're seeing this changeover in thinking of a conventional versus a centralized approach versus a decentralized approach. And this will work in either one. I think it's the U.S. is still more or less still centralized. I know within Europe they are moving to a much more decentralized approach. But in either case, you can still use the XMPP type system to do that. And one of those applications is use of microgrids. And again, you can see how XMPP, which right today, which I'll talk about this in just the closing moments of my presentation, they're building XMPP into setup boxes, which you may put into your home. And your censored systems that are collecting information from inside the premise or within a building, they can forward their data traffic through an XMPP connection over the internet, which may be over your cable or your fiber connection or even a wireless connection. And of course, the home automation area is a big one, which I was just contacted by the Universal Plug and Play people who have decided that they're going to use XMPP for participating as part of the Internet of Things. That was really interesting because there's a lot of devices in the home that all use Universal Plug and Play. And of course, I didn't show it on here, but obviously the electric car is using IEEE standards, and there's a need to send communications about charging of those types of things, electric cars and other types of devices, because I imagine there'll be even more electric types of vehicles that will hit the market. So XMPP is going to be useful, I believe, in this area. This is one of my final diagrams, but I got this from one of our participants who is in Sweden. And this is a diagram from KTC, who is deploying a 100,000 node system in Sweden. And it will use XMPP with the same basic architecture I've been talking to you about, and be able to tie that into mobile devices so people at home can monitor. They use a lot of heat exchangers in Scandinavia, for example, and of course the utilities want to monitor those and their usage. Some are using legacy protocols, including BACnet as well as Modbus, but then there's also this need to tie in mobile devices that's necessary. Okay, that kind of closes it out. I obviously could say a lot more, but let me just turn it back to you, Irfan. That kind of covers a broad amount of information.
Great. Thank you so much, William. And it was quite a broad stroke, and it had very, very detailed information about the XMPP protocol, but then also I like the way that you put it in the context of things that are evolving now. There are some questions that are coming up, so I would like to start with those questions and then ask the audience to add further in the chat window. We will start with a question from Paul Duffy, and Paul asks that, let me see if I can get this question going here. So the XEP332 looks more like HTTP mapping to XMPP than a tunneling technique. That makes more sense. That was a question, a comment from Paul. And then
Irfan, did you send out the white paper that I sent you?
I will be sending it out tonight as an attachment with the presentation and.
Okay.
Yes.
Yeah, that'll help that gentleman. Which there's a white paper I gave to Irfan from Kleister Research, which is quite detailed, talking about this whole thing of using HTTP over XMPP. It's not really a mapping. It is establishing a tunnel, as you said, in the form of, as I showed you in the diagrams, using EXI. Then you can encode, if you're doing a legacy protocol like OPC UA, you could encode that. Some people have been doing this with their own encoding right now, but would like to see if they can use the EXI capability. But I think that'll help. If you've looked at the one on the web, that's good. But I think the white paper will be even more helpful.
Okay, so Francis Bell asks, what are examples of smart grid projects that have begun to implement these ideas? Are there utilities using these tools, or is it mainly third-party companies selling products to utilities?
I'm going to say most of the areas of use from the smart grid utility perspective that I've seen have been happening in the EU right now. Places like Germany, as well as Scandinavia, like Sweden, Italy, Spain, they've been very active in use of XMPP. When you're using XMPP, it's also, I didn't talk about it in the presentation because I thought it would take too long. It is actually being used for first responders, and there's some systems that will be coming out very shortly that provide alert mechanisms. So you can tie in the sensors within the utility grid to provide alerts, and how they route those messages will be determined by whoever decides to set up that service. But that will all use XMPP.
All right. And then Stephen Dawson provides some information. He calls it XEP-0323 Internet of Things sensor data, and he provides a link. And then he says, how are you handling message security with actual sensors, SSL, SA, SL, TLS?
I guess I want to understand the question because you mentioned different encryptions of TLS, SSL. We use TLS as the basis in XMPP, but you would be able to send, once you're using HTTP over XMPP, you could send your standard HTTP data traffic and encrypt it in whatever you wanted to, because it would be encoded at that point. But the standard that's used with XMPP is a TLS capability.
So let me ask a question relating to this. On your OSI stack, the 7-layer model, where exactly does XMPP reside? Which layers does it cover?
Well, it's at the transport layer. It's considered an applications layer router capability when you use it at in your server. So again, if you were securing something lower at your MAC-PHY, that's totally separate. Again, that's part of the technology that you're going to use. It's totally separate. I think one of the nice things of using the TLS the way we do is you're able to get an end-to-end security capability. And even though you may provide this over different types of physical technologies, wired or wireless, doesn't matter, you're able to get at least an end-to-end connection with the endpoints, or to multiple points for that matter.
So it seems to be more of it doesn't fall into the standard OSI model. It seems to have touch points at different layers in the networking part and in the application part. You did mention it's agnostic to the by-MAC layer. It seems to, when you are talking about running HTTP over XMPP, there seems to be a little redundancy in the layers from an OSI perspective. Am I correct in understanding it that way?
I don't think so. Again, HTTP, I can't comment a lot on because it's just standard web page type data traffic using HTML. So in this case, you're going to maybe be able to send that. If we're talking about the sorry, this nomenclature skipped me. HTTP over XMPP, you would encode that data, which may be even XML, over the link that you're going to connect for XMPP. So it's still using, the same kinds of transports, but I guess it's different in the sense that the application has the XML constructs that provides the semantic signaling between server, client, server to server, and so on to do that.
So what you're basically doing by introducing XMPP is providing additional security controls that are not there when you're doing just the traditional TCP/IP stack on a 5-MAC layer, and you're adding a lot of security controls from outside, like adding the TLS layer, end-to-end. Here, what you're doing is in the protocol itself, you're building in those security controls so that you can enable TLS, for instance, within the XMPP?
Right.
Okay.
That's exactly right.
All right. Okay, that makes sense.
And of course, you could still use all those other security things, but they're, even today, when we do it, once it hits the endpoint, it's no longer encrypted anymore or secured.
Okay.
So
there was a question about bandwidth, especially with constrained networks, low power, narrow bandwidth networks, where it's already a challenge to deal with XMPP and HTTP on their own. But when you ride HTTP on top of XMPP, how are you going to do that? Is there enough compression from the algorithms that you were talking about to offset that problem?
Yeah, well, as I understand it, the encoding, it's a Huffman encoding if you're using EXI that can reduce the data stream for about 90%. I know I've had this question about using it with relatively low bandwidth devices. I'm not sure that it's 100% applicable in that area. It depends what we're talking about. But of course, if you think back, we used to send things over 300 baud modems that was still HTTP, and that was before we used a lot of compression. The only thing you got was in the modem. So I would be surprised that you couldn't still get, XMPP data traffic even over low bandwidth types of connections. But of course, in my opinion, I don't think we're looking to replace a lot of those existing systems out there. I mean, if you were using modems out to your substations today, is it really something you need to replace with an XMPP capability? Not sure. If somebody comes along and promotes something like that, and they've tested it and certified that it still performs all the functions okay, maybe they'll do that. But for right now, I don't think that's really been a concern. At first, I thought you were going to ask the question about the constrained memory types devices. I really feel like that's going to be something. Is that what you were asking about?
Yeah, that would also be, I mean, first it was the pipe, and then, of course, it's the endpoint and what impact it will have on these devices that are relatively constrained from memory and processing capability.
Okay, bear in mind, in the case of using an RFID reader with a device, you still use the same RF connection to talk to the device. Of course, you could also embed the RFID device into even a thing like an iPad or something like that. That way you actually have access to the memory directly on board the RFID chip. We're not using XMPP anywhere in that aspect. What it gets you is the ability of having a relatively small file that provides a lot of useful information. And if you were using the Qzip I mentioned, then you could put that on board your RFID device. Your reader reads that file, and then it reconstructs it on board the device. Then, if you need to communicate back to a server, then you may use XMPP, or you may use something else. I mean, that compression capability and what I just described is not tied specifically to using XMPP.
Okay. The question from Stephen Dawson was, are you doing anything with Powerline Communication? And I saw you gave an example of broadband over Powerline.
Yeah, as long as you can establish a connection, broadband over Powerline would be great.
Okay, and would you also extend this into the home, like using Green5, for instance, for home plug?
I don't see any reason why not, because a lot of the systems that are like HomePlug and others, they're designed for in the use of the home using 802.15.4 or some other radio technology. And what we're talking about here, that if you wanted to extend that from the premise now to at your gateway or setup box or something you have in the home, then you basically put a XMPP capability there. Gather it from your censored system, and then it can provide it back to through the internet to whoever needs to get that information, whether it's the utility, a third party, or whatever at that point.
Okay. And then what are some of those additional security controls that HTTPX has over HTTPS? You mentioned that during your presentation that this could be a new extension. So what are those additional controls that you...
Let's compare the two. The HTTPS, of course, sets up an SSL session with your web server.
Yeah.
Okay. If you're using the HTTPX, X is an X-ray, then you'll communicate to your broker, and the broker is an intermediary. It's not unlike if you were making a phone call in the past. You might have called to the operator and says, I want to make a phone call to Airfan. And then he makes sure that you're online, make sure it's really you, and then he says, oh, Airfan is online, he's ready to talk to you. And if we want to then have others join the call, that operator kind of takes care of all that. But all this happens just in a few milliseconds. If we're already registered, you and I, or our devices. They're registered. You just turn them on, and they would authenticate and be ready to communicate with each other.
Okay, so the distinction is not so much in how robust the encryption scheme or all of that is, and once the pipe is established, it's more about authenticity before you establish the session.
That and the fact I mentioned earlier about that it being firewall friendly, it greatly simplifies having to do a lot of special configurations of your firewalls. I mean, you would want to have a firewall on all these endpoints, but this is kind of a problem when you think of things that are inside the enterprise and you want to send this information to somewhere else. You would have to do a lot of things to open up the port to allow that traffic to get through. Many places just don't allow it to be done right now. You know, they'll block that kind of access. And these are kind of things that I think are going to be very helpful to be able to allow the enterprise, the home, an industrial facility to be able to have that information shared to people they trust to do that. And I think that's another element, is that the brokerage approach is a trust relationship between devices, users, and the applications. And that's really, I think, an important element that we really don't have right now built into the way the system does it.
Okay, good. Robbie Simpson asks, from a technical perspective, ignoring market presence, tools, etc., why XMPP as opposed to COAP or HTTP/1.1 or upcoming HTTP/2.0?
Please forgive me if I don't remember all the details of some of these, but there's obviously different approaches that people are trying to take to solve these problems. You'll have to look closely to see comparatively. I'd have to look at it myself right now just to compare those differences. So I'm not sure I can sufficiently answer his question for him right now without a little research myself.
Okay, so why don't I act as your intermediary, and if you could provide that information in the next couple of days, I'll connect you, Robbie.
Sure. We'll get that question again, and any other questions, I'll be glad to answer them.
Yeah, they're involved in the development of a lot of smart appliances over at GE, and he'd be very interested to know what are these value adds of XMPP over these other approaches. Next question is from Pavantan Arumugam, who says, how does XMPP compare to the COAP, which is also getting developed at IETF? So I guess both of them could be answered
right
the same way. And
I remember looking up the COAP before, but I can't remember the details of how they're trying to address that.
And then Randy Turner says, has there been any comparison or analysis at using MQTT, proposed OASIS standard, versus XMPP? And this was also asked by another individual in the audience.
What was the first part before what you said, OASIS? What was the name? Or
MQTT.
Oh, yeah. Well, I've been following that one closely, too. MQTT or PP?
TT. Yeah.
Yes. The one why that worries me a bit is it just kind of raised its head in the last year. It was developed by IBM over in the UK, and they are trying to push it through the OASIS people to get it standardized. I'm just a little uncomfortable myself. Not that we won't still use it somehow. I think it needs some help. It actually was developed by people who are hackers. So at least when I looked it up on the web, and that's my exposure to it, is it's been used in certain applications, railroad yards and other places. They've had a lot of meetings over in Europe right now. But again, I feel like there's still something that we're not being told about it. Even if it can make some type of communication, I got to look much more closely at it. It may be something that we'll use with an XMPP type of infrastructure, But I'm just a little uncomfortable myself that it actually was something that I found was coming from people who basically were hacking a lot of things, and that worries me.
Okay.
I feel like I'm giving the gun to the people who are the hackers to show them how to do it. You know.
Yeah. I think what would be very helpful, William, since you're deeply invested in this development of this protocol, this particular standard, is to show it in a very objective way, put it in a little spreadsheet, the implications on bandwidth, the new security controls, the ability to scale up, those types of non-functional things, and then show the comparison of these protocols. Because for the lay population, each of these standards is being driven by established people in the industry. And what we need is an objective dialogue on metrics that are very clear-cut so that a person knows that if they're designing a system XYZ, what would be the best protocol to use given what their needs are, as opposed to saying such and such group is promoting it, so I should go with it, whether it fits or not. We need a more objective analysis of these various approaches. I mean, we've already heard 3 or 4 in the questions.
No, that's true. I mean, you have to do a lot of research right now to do the comparison, and a lot of these things you're talking about, it's only in the last few years that they've entered into this discussion. I might mention the ones that we've just mentioned, they haven't approached IEEE, they haven't approached ISO to become standards. They've all decided they were going to take somebody like Oasis or some other standards direction, if you will.
Yeah.
So it gets to be a contention with what IEEE and ISO are doing.
It becomes very challenging for utilities and also for the vendor community whose main focus is either to deliver electricity or to make products when all of these standards are floating around, because unless we peg them down to very specific use cases and show what the value add of a particular standard is, it becomes very difficult. Then you're relying on appeal to authority. And while IEEE and IEC are established and respectable organizations, there may be a need for a different kind of protocol that has not gone through that process, but there's a business need for it. So I think what we need to do as an industry is to have more objective discussions on this so that it's not an existentialist war between standards, but one of relevance. Next question we have from Amini, who says, please explain more about the Sweden project.
Well, actually, I was just looking to see who was online because I invited some of the people to join the call. But again, I can't give you a lot of details right now, other than I know that people like Cisco, as well as Ericsson and several other large companies are involved in supplying aspects of that project. And I know the Swedish government is committing a lot of money to doing these things. I mean, they have a large fiber-based architecture already, but of course they also have wireless. I mean, Ericsson actually comes from Scandinavia. Telefonica is another large telecom in the area. But there's many other ones in the EU, and I might add, the people in Europe are doing things differently, just like we're seeing in China. China may participate in our activities because they'd like to be part of those standards, but they are making their own as well. And they have a lot of smart people. So it's hard to say. I can't give you a lot of detail on that, but I would say watch the news within the next maybe 60 days because, I don't want to give away the farm for what they're doing in any other marketing-related aspects.
Okay, so I guess the next question would be difficult to answer. How much budget was assigned for this project? So,
I know, but I probably shouldn't replace it, but it's a lot of money. Yeah.
Okay. The next question is, please address the same types of questions with my PLC question above. Thank you. So I guess that was addressed. And then Randy Turner says, you still have to configure the firewall to allow the port number being used by XMPP, correct? By default, most firewalls would block XMPP. I was under the impression that you were talking about having that trusted broker, and then there would be a policy to allow things coming from them, but it would still be a particular port number from the trusted partner, correct?
Right. You still have to, you would still open up that particular port, which is assigned for XMPP capabilities. But again, since it's not down at port 80, you're not getting those same exposures, which I really like a lot.
Yes. But how about all of these hackers who sit around and do port roving looking for vulnerability? Would they find that this port is active and it's moving XMPP traffic? Is there a way to cloak that? Is there a way to cloak that somehow?
Well, again, you have to use the XML constructs. You have to communicate to the broker and provide the recognition. And of course, you still would use, you know, I said this is technology agnostic. So when you made your connection, whether it's broadband wireless, over your wired connection, you'll still set up whatever is at that MAC-PHY layer and so on. I think that still pretty much helps out a lot, that you've got firewall capability, obviously being more friendly, but if you're leveraging the broker then is what allows you to set up the connection between the endpoints. And again, we don't do that right now. As I said, when we just call to go to your bank or anything else, you just do a login and a password, and they set you up an SSL connection. But you don't really know for sure. Anybody could do that, by the way. That's not for sure that you're really talking to who you think you're talking to. But we haven't totally eliminated everything, but it combines a lot of capabilities that tends to be layered on right now. So I think that's going to be even more helpful.
Okay. And then Paul was just making a comment from Cisco saying that they support OASIS MQTT as well as XMPP and COAP. So it seems like in the presence of all of these protocols, vendors are kind of on the fence and accommodating everything until there's a clear-cut way of solving a particular business problem with a particular protocol. I'm not seeing people gelling around one, so it seems like there will be some plurality in this space for a while.
Yeah, I wouldn't be surprised. In fact, Cisco is one of the ones that will be supporting XMPP, which I know there's some activity there to build it right into the routers, which should be really powerful. In fact, even the head of the XSF is from Cisco, matter of fact. So Peter St. Andre is from Cisco and been along with the XMPP Foundation since pretty much the beginning. And I do believe that we're going to see this migration of XMPP service capabilities move into the routers that are used throughout enterprises as well as the internet. And like you just said, there's different protocols that people are using in different spaces, and obviously the vendors will want to accommodate all types of different protocols. And it's really up to the the end user who decides he's going to implement something, which one he feels that he wants to try to use. There's nothing that's going to stop that, and obviously we want to work with everyone if we can.
Great. Well, I appreciate your presentation, and it is definitely demonstrating an evolution in our thinking about how to communicate with devices that are geographically distributed across multiple trust domains. and to build in certain security controls so that we have greater confidence that we are talking to the right people when we are sending and receiving information, and that we are making it as difficult as possible for hackers to come in and disrupt that communication or do data fuzzing and other of nefarious acts. So I appreciate the presentation, and the presentation and the webcast recording will be sent to all the registrants tonight. So you should be receiving that, along with the link to the white paper that William mentioned earlier in the presentation. Our next webcast is actually going to be a seminar, and it will be hosted by TUV Rhineland in Pleasanton, California. They've been very gracious and have been inviting us once a quarter to come and present there. And I will be your presenter, and I will be doing the third part of my series on electromagnetic theory and its applications now in the grid. So we'll be talking about how electricity flows in the grid, what types of protocols are used to control that, and how are they proliferating, and where are those boundaries where they can exchange information between each other. You saw some of those protocols mentioned by William in his presentation today, things like Modbus and BACnet, and then if you look in the distribution network, there is DNP, and also in the transmission network, there's DNP. Then there's IEEE 61850, which is for substation automation. So simultaneously, we're seeing the presence of multiple protocols, and if you lay them all out on the smart grid, there are some overlaps, and there are some areas in which there are two or more standards working in the same domain. So some utilities in their infrastructure using one protocol versus another one. So it's important to understand that landscape and understand what are the features of the protocols, what are their pros and cons, and where are they going. So the presentation will cover a little bit of the application of the physics, and then we'll get into the protocols. I'll also be talking about how electromagnetic waves are actually used to carry information. How is digital information encoded in electromagnetic waves? And then talk a little bit about the interference issues and some of the path loss issues that are there, and what impact that has on both grid operations as well as in controlling smart appliances in the customer prem. So with that, I want to thank you again for participating. As I mentioned, the next call is going to be on September 26th. It'll be a Thursday from 12:30 to 2. And we're going into this format where we'll be doing things on the second Thursday and the fourth Thursday of the month going forward. So with that, thank you again, and I will bring this recording to a close and this webcast also to a finish. Thank you very much. Bye-bye now.
Thank you, Erfan.